Here's number 9 from section 3.3. We're given a position function. X of t equals the inverse sine of t over 4. And we're asked to find the velocity of the moving particle at t equals 3. So the first thing we're going to do is just find the velocity function. So v of t we know will be the derivative of the position function. V of t is x prime. So we have an inverse sine function, and I know that the derivative of an inverse sine looks something like this. 1 over the square root of 1 minus what's inside the inverse sine quantity squared. So that's a t over 4 quantity squared. And then use the chain rule times by the derivative of t over 4. And if you think about t over 4 as just being 1/4 t, the derivative is 1 over 4. So simplified, this is 1 over a 4 times the square root of 1 minus t squared over 16. Now, there are ways we could simplify that derivative a little bit, but I don't think we need to, since the goal of this question is to evaluate at t equals 3. So let's get started there. V of 3 will be 1 over that 4 times the square root of 1 minus 3 squared over a 16. So let's keep moving. We now have 1 over 4 square root of 1 minus 9/16. And then that becomes 1 over 4 times the square root of 1 minus 9/16 is 7/16. So we could say we kind of have an answer here, but this isn't very simplified. The first thing I notice is that the root 17/16 we can think of as root 7 over root 16, and the root 16 is a 4. So now I'm looking at 1 over 4 times the square root of 7 over 4, and those 4's conveniently cancel. So now I have a final answer of 1 over the square root of 7, which is okay. Or if we rationalized, we would have the square root of 7 over 7, and that's number 9.